Alright, this was the second most missed question on the problem set. This is a tricky one. There's quite a bit you got to kind of consider with this. First thing that we know is we know that secant is defined by 1 over cosine. Right, cosine is going to be 0 at pi over 2. So we're going to have to break this in two pieces and think about it as an integral from 0 to pi over 2 of secant squared x dx plus an integral from pi over 2 to pi of secant squared x dx. Now, depending on how comfortable you are with the graphs of these, you might know something about symmetry that would allow you to condense this. I'm going to go under the assumption we don't, since it's a non-calculated part of the test. Alright, so I'm approaching an issue spot as I go to pi over 2, so I'm going to say the limit as x approaches, we'll call it a actually, a approaches pi over 2 from the left, alright, of the integral from 0 to a of secant squared x dx. And I'm going to start with this piece because the next piece is going to actually end up behaving in a very similar way. Alright, so next thing I'm going to do is I'm going to go ahead and evaluate that antiderivative. So I've got limit as a goes to pi over 2 from the left, alright, of tan x from 0 to a. So I still got limit as a goes to pi over 2 from the left. All right, I'm going to plug my tan in, so tan of a minus tan of 0. All right, so that's really limit as a goes to pi over 2 from the left of tan a minus 0. All right, so now I'm looking at tangent, and on tangent, as I approach pi over 2 from the left, all right, we know that tangent shoots off towards infinity. All right, so technically that grows without bound. Or a lot of times we just say equals infinity. All right, so if that equals infinity, that tells me that that integral diverges. All right. And if that integral diverges, then the other one's going to diverge the same way because we really have the same function and we're just approaching the value from the other side. So on this one, what I would look at is my choices. The integral equals 0. We know that's not the case because we are divergent. The integral equals 2/3. We know that's not the case because we are divergent. The integral diverges because the limit as x approaches pi over 2 from the left of secant squared x does not exist. That wasn't the limit that we dealt with. So then we get down to the last one, and that is the limit that we encountered as we went through this improper integral. All right. So this problem really focused in on the improper integral and also recognizing that this graph does have a discontinuity that's infinite, and we're going to have to look at it coming in from both sides. Hope that was helpful.